What does it really mean? It means find P0 plus P1 plus P2 plus P3 plus P4. So the plus means add all of them together. So I can use any method, but I just want to refresh our memory. What is P0? What is P1? What do they mean? All right, whenever someone uses P0, P1, so P0 actually means use binomial formula to expand. So let me make sure we remember what P0, P1. So P0 is equivalent to sample size is 13. So 13 combination 0 multiplied by success to power 0, 0.35 to power 0, and multiplied by failure to power 13 minus 0. All right, so by the way, failure is 1 minus 0.3, 1 minus 0.35, which is the same thing as 0.65. 13 minus 0 is 13. 13 minus 0. I want to also remind of the formula, binomial distribution formula. The binomial distribution formula, which you will be expected to know, is n combination R or X. R is the number you want at a time. Number you want at a time. Success to power R. R is random variable. You can use R. And failure to power n minus R. Okay, so you see that I have n combination R. Success to power R, failure to power n minus R. That's exactly what I have expressed above. So that's exactly what I just expressed. 13 is sample size, combination 0, because I'm looking for P0. Success is 0.35. I'm going to take away one to the small point. So I'm taking this one away. All right. Success to power 0, random variable. Failure. See, failure is the same as 1 minus 0.35. Remember, binomial distribution is binomial, and there are two events, success or failure. Success is P, failure is Q. Therefore, if I'm looking for failure, then I do failure minus success. That is 13 minus 0. Okay, so that is P0. Now, when I'm told to find P1, we did it last week. Just want to make sure that I refresh your memory again. So I know the formula, so I'm going to clear that formula now. So you can actually do them individually. So you find P0, then you find P1, then find P2, and add all of them together. What is P1? You can be told to find them individually, like I'm doing now. P1, all right, is 13 combination 1. 13 choose 1. Success does not change. Success is always going to be success. Success to power 1, failure to power 13 minus 1. 13 minus 1 is 12. Okay, what I'm told to find P2, and after P2, I would like you to finish the rest. When I find P2, it is 13 combination 2, success to power 2, failure to power 13 minus 2. And I can write that failure as 1 minus success. To power 13 minus 2 is 11. And so on until I get to 4. And I will add P0 plus P1 plus P2 plus P3 plus P4. When I do all of them, I'll get the answer. All right, but there is a quicker way of doing it. So we're going to do it the quicker way. I'm going to show you how to do it again using the calculator. Let's do it the quicker way. So I'm going to clean everything I have written so that I do it the quicker way now using at least. Whenever the binomial distribution says calculate the random variable less than or equal to x less than or equal to the random variable, it actually means at most, not at least, at most, sorry. So I'm going to be finding at most binomial distribution using the quick method. So first of all, I'm going to write it down. So binomial CDF, binomial cumulative density function, sample size, probability of success, and the random variable. Today, the random variable is 4, and I'm accumulating to the left. The most thing to note is that it's binomial cumulative density function. So you must know it is cumulative density function because there is also binomial probability density function. You want to make sure you're accumulating. So then after that, I will get my calculator. So I will replace n. I will replace n. This is x or r. But I will replace n with 13 sample space. Replace p with 0.35. And then x is 4. Then the next thing I want to do is get my calculator. I want to make sure I show you where it is again today. How do I use my calculator to calculate at most probability for binomial distribution? How do I use my calculator to calculate at most probability using my calculator? So I'll go to second distribution. I am recording this in case you want to go back and watch it. Hopefully it's going to record. So normal, I'm going back to second distribution. I am not looking for normal distribution. I'm looking for binomial distribution. So I will arrow up and start looking for binomial. But remember, I'm looking for binomial cumulative density function. This one right here. So I will select that. That is B. My calculator is asking me how many trials, sample size. So how many trials is sample size is 13. What is the probability of success? That's the next question. 0.35. What is the value of the random variable 4? I'm accumulating to the left, so 4 is included. Then I am going to paste. So I'll paste. My calculator is asking me, is that what you mean? Is that what you want to calculate? At this point, if this is not what I want, I can arrow in and I can just arrow in and correct it. But this is what I want. Suppose I don't, that's not what I want. I can go back and correct that. So now that I have put it in, I can hit enter and it should give me my answer. It tells me that my answer to the nearest 1,000 4 decimal places is 0.5005. So the probability of at most 4, the probability of at most 4 is 0.5005. 0.5005. And this at most 4 is something as P0 plus P1 plus P2 plus P3 plus P4. All right, so we have already seen that we can be given to find the probability of at most 4. All right. Okay, so now that I know this, I can write my answer here, 0.5005. That is the probability I'm told to find. Now, I'm going to tweak this question. So I'll tweak the question. In this question, everybody can see that I'm told to find the probability of x less than or equal to 4. What if my question, what if everything remains the same and I'm given x, and I'm given x greater than or equal to 4? Well, this question is an at least question. Whenever you are given the random variable is greater than or equal to, then it is an at least question. So in this case, I'm told to find P4. I'm starting from P4 plus P5 plus P6 until I get to P13, because sample size is 13, and I'll add them together. Alternatively, I can use the quick method. And if I have to use the quick method, then it means that I will do what is called the complement rule. So I'm going to use the quick method now, and I'll do the complement rule whenever I'm told to calculate the probability of at least in binomial distribution. In binomial distribution, whenever I'm given the at least probability, I will use complement rule. Okay, so what I'm going to do is 1 minus binomial cumulative density function, sample size, success. Now this time, because 4 is included, I have to do 4 minus 1. I have to do, so anytime I'm doing at least probability, I have to do random variable minus 1. So this has to be random variable minus 1. Why? Because if I subtract 4, then I have changed the question. If I subtract 4, I have changed the question, because actually I am told to cumulate from 4 to 13. Therefore, if I'm using complement rule, I will subtract P. So I will only throw away P0, P1, P2, P3. I will throw them away. P0 is not included. P1 is not included. P2 is not included. And P3 is not included also. So to make sure that 4 is included, I have to cancel P1, P0, P1, P2, P3. Okay, now let's do that. I'm using my calculator. I want to make sure you know how to do this. So I'll do it again. So I'll pull my calculator up, and I will do 1 minus binomial CDF. In fact, I can bring this down, but let me go back to second distribution, and I'll look for binomial CDF, cumulative density function. That's B. I'll select that. And the sample size is 13, the same. Success is still 0.35. The random variable here is 4, but it should be 3. Because I'm subtracting this, I'm taking this one away. So what should be there is 3. And then I will paste. When I paste, look at how it's going to be. Let me see. Did I put? Yes, I put 1 minus binomial CDF, sample size, probability of success, and random variable minus 1, which is 3. 4 minus 1, which is 3. When I hit enter, my answer is 0.7217. 0.7217. Therefore, the probability that I can get numbers from 4 to 13, numbers from 4 to 13 is 0.7217. 0.7217. That is the probability that I can have a random variable x greater than or equal to 4. Random variable x greater than or equal to 4. So whenever it is greater than or equal to 4, it means I am doing at least. At least means 1 minus complement rule in probability. At least means complement rule. All right. So we are done with binomial distribution. We will see it again during our review. We shall start reviewing maybe next week. Our test, as soon as we finish with binomial distribution and central limit theorem. So we're getting into, binomial distribution and normal distribution. So we are starting with normal distribution today. So that next class we shall start with, next class we shall do central limit theorem. And after this week, next week, we'll start review. We'll start review next week after central limit theorem. Central limit theorem is 8.1. So right now we're going to get into continue with normal distribution. We have normal distribution before in unit 1, but it's important that we go back and mention them. Actually not mention it. We're going to do a whole lot of it just to make sure we know how to do normal distribution, because central limit theorem and normal distribution are the beginning of unit 4, which is going to be the next unit after unit 3. All right, so I'm going to clean this and look for a question that is on normal distribution. So we're just done with binomial distribution. Remember the properties. The most important properties are the name says it all. The binomial distribution has 2 events, success or failure. Sample size must be given, and the success must be given to you, and then you can find failure. So P plus Q equal to 1. Why? Because the area under the normal curve is 1. The rules of probability says that the sum of all the probabilities must be 1. And there will be no negative probability, because binomial probability is also probability. It has to obey the rules of probability. All right, so the next thing we want to do now is look for a question that is on, going to get a question that is on normal distribution, so we can refresh our memory before we get into central limit theorem. So let's look at this question number 25. Question number 25 says, determine the total area under the standard normal curve in parts A through C. So actually, in this question, in number 25, there are 1, 2, 3 questions. And yes, this kind of question are in the test. So you can be doing 1 question, but there are 3 parts in that question. That's why you need to have the speed and accuracy. The most important thing is that you know when you are given normal distribution, when it is binomial. Um, Also, very soon, I don't want to do central limit theorem with anything, so I'm postponing central limit theorem to next class. So next class, we shall discuss central limit theorem. But you need to remember your normal distribution before you go to central limit theorem. All right, let's start from number 25. Question 25. So we're told to find the area under the normal curve to the left of z equal to minus 2 plus the area under the normal curve to the right. Let's see what the right says. To the right of z is equal to 2. In other words, the question is asking us to find the area under the normal curve for x, or I can say z for plus or minus 2. Well, this one actually answers itself because according to empirical rule, the area under the normal curve, it says between. So if I can actually use empirical rule, this is a question that you can actually use empirical rule there. Empirical rule told us that the area under the normal curve, so I'm told to find the area to the left, but I can as well use empirical rule. So the center is 0.95. According to empirical rule, 95% of data lie within plus or minus 2 standard deviations. All right, so this is minus 2 standard deviations. This is plus 2 standard deviations. I remember I can write a z2, then z is to plus 2. One thing you need to know is that, remember, is that area under the normal curve is 1. So if the area under the normal curve is 1, then I can actually, so 1.00 minus 0.95 is 0.05. So that area under the normal curve is 0.05 or 5%. Remember, area under the normal curve can be written in percent, decimal, or fraction. So you could be told to write it in percent. Why? Why is it 0.05? Because the area in the middle is 95%. If the area in the middle is 95%, and the total area under the normal curve is 1, then it is 1 minus 0.95. So that is why the area to the left plus area to the right, I'm talking about this area plus this area. In other words, if I divide 0.05 by 2, if I divide this by 2, divided by 2, I will have 0.025. Therefore, this area is 0.025, and this area is 0.025. 0.25. So what if I want to use my calculator to get this? What if I want to use my calculator? Okay, let's do it with calculator. Let's do it with calculator. So now, suppose, let me just check my answer with calculator. So I can actually use my calculator to find the area to the left of z equal to -2. Then multiply it by 2. Why? Because normal curve is symmetrical. If this is -2, this is 2. And area cannot be negative. So area to the left will be equal to area to the right. So normal curve is symmetrical. If I know the area to the left of -2, then I also know the area to the right of 2. So if I can find this area, then I multiply it by 2. So let me get my calculator. It's good to use our calculator so we can review also. So let's find the area under the normal curve. Now remember, we're talking about normal curve this time. This is not binomial. So at this point, people will start mistaking binomial with normal. People start mistaking binomial with normal. No, we're talking about normal curve right now, area under the normal curve. Okay, remember the argument before. Before I go ahead and calculate, let me actually write the argument. So I'm going to write the argument right here. What do I mean by argument? What you should put in your calculator. So you are now going to put this in your calculator. And then remember, we still have to do how to do it by hand. I mean, using your chart. Okay, so you will do normal distribution this time. So normal cumulative density function. Normal cumulative density function. So this time, when you get into your calculator, you are not going to be looking for binomial. You'll be looking for normal cumulative density function. All right, so I'm told to find the area to the left of -2. Remember, the argument is lower bound, upper bound, mean, standard deviation. That is the argument. And so what is the lower bound? Lower bound is -2. Actually, lower bound is negative infinity. Why? Why do I say negative infinity? To the left of -2 is negative infinity. And I want you to remember that your calculator does not understand infinity. So you cannot just put infinity there. You can't put negative infinity there. No. You must type in -1 to the power 99. So I will feed this in my calculator now. So normal cumulative density function, negative infinity, -1 to the power 99. And the upper bound is -2. The mean of a standard normal curve is 0. The standard deviation of a normal curve is 1. So this is what I'm going to tell my calculator. All right, right now I have written the argument on my paper. I want to calculate. So I'm going to feed the argument in my calculator. Where do I go again? I'll go to distribution, second distribution. And number 2, because I'm looking for normal CDF, normal cumulative density function. The lower bound is -1 to the power 99. I'm going to clear that so I can type it again. Negative. You have to use this negative because that's the first number. -1. Do you remember where to find E under comma? So second comma to the power 99. This represents infinity, negative infinity in our TI-84 calculator. The upper bound is -2. The mean of a standard normal is 0. The standard deviation is 1. I'm going to paste. So it's going to check that did you type in what you want correctly? Yes, I did. And if I did not, I can go back inside and do corrections. So it's giving me an opportunity to do corrections. So, and then I will hit enter. It told me that the area to the left is almost, using my calculator, the answer is more accurate though. So the area to the left of -2 is 0.0228. So that area is 0.0228. Okay, so 0.0228. 228. This is a more accurate answer. Your calculator gives you a more accurate answer. Then you multiply this area by 2. Why do you multiply by 2? Because you're told to find the area to the right of 2. Area to the right of 2 and area to the left of -2 at equal. The normal curve is symmetrical. The normal curve is symmetrical. Okay, when I multiply by 2, my answer will be approximately equal to, let me go ahead and put it in my calculator. See, my answer will be almost 0.005, but it will be less. So I'm going to multiply this by 2, multiply by 2, and my answer is 0.0455. So this is my calculator answer, and my calculator answer is more accurate. But anyway, if you write your answer as 0.05, we shall still take your answer. All right, so according to normal distribution, remember we already talked about the properties of normal distribution. Area under the normal curve is 1. The mean divides the normal curve into 2 equal parts, 50% to the right, 50% to the left. The tails go to positive infinity to the right and negative infinity to the left. The normal curve does not touch x-axis, but it runs asymptotically to x-axis. Okay, and so on. All right, so now we have calculated, we have done question number 25A. So let's go ahead and do question number 25B. This is normal distribution. So we started with doing, all right, so I'm going to clean. So we did a normal distribution, part 1 or part A of number 25. As I said before, if you're just coming in, this unit contains chapter 6, and chapter 6 is discrete probability distribution and binomial distribution. Chapter 7, normal distribution, and chapter 8.1, central limit theorem. So today we are in chapter 7 again. We are talking about normal distribution. This is a continuation actually, because we already started normal distribution from unit 1. Okay, so making sure we can solve problems in normal distribution. We are solving problems in chapter 7. Okay, question B of number 25. It says find the area under the normal curve to the left of -1.54 plus the area under the normal curve to the right of, let's see what right says, to the right of positive 2.54. Now watch this. These numbers are not the same. The absolute values of these numbers are not the same. So you cannot just find 1 and multiply by 2. The absolute values of these numbers are not the same, so you have to find them individually. So let's go ahead and find them individually. So the first thing you want to do when you're told to find the area under the normal curve is to draw a normal curve, draw a picture. So I'm going to draw a picture. What picture? A normal curve. So I'm going to draw a normal curve, show the numbers it should not touch. I'm trying to find the area find the area under the curve to the left of this. So this is -1.54. And to the right of 2.5. 2.5 should be somewhere here, 2.5. So I'm trying to find area, this area, and this area, and add them together. I already said that the absolute value of 1.54 and 2.5 are not the same. So I have to find them individually. So what am I going to do? I will find the left-hand side. So the left-hand side is normal cumulative density function. Lower bound is negative infinity, -1 e to the power 9. Upper bound is -1.54 mean is 0, standard deviation is 1, and I will add it to normal cumulative density function. The lower bound, because 2.5 is smaller than positive infinity, 2.5. Upper bound is 1e to power 99. The mean is 0, standard deviation is 1. Then I calculate both of them, add them together. I calculate them, add them together. All right, so I can get my calculator and do that. So you're gonna watch how I am going to put them in my calculator up. Remember, in this class, you are allowed to use your calculator to solve any problem or the problems, provided you have the speed and accuracy, provided that you know how to do it with calculator. So therefore, being able to solve the problems with your calculator is one of what we are testing. You should be able to solve the problems with your TI-84 graphing calculator with speed and accuracy. Why? Because you're given 20 questions, and some of them can be ABC, and you are required to solve them in 90 minutes. So it's not just what you're going to be wasting time. You want to complete the questions. You want to make sure you are doing well, completing the questions and making a good grade. So that is why I will give you the practice test ahead of time. So you start now to practice for the test. The test is not until the 30th of this month, and today is the 10th of March. So test will be 30th of March. Okay, so let's start. We calculate the area to the left first. So second distribution, second first, which is distribution. I'm doing normal distribution. So normal CDF number 2. The lower bound in my argument is negative 1e to power 99. The upper bound is negative 1.4, negative 1.54. So negative 1.54. And the mean is 0, standard deviation is 1. So I can paste that answer and check. Yes, I put it right. So I hit enter. So I got the first answer. Then I'm going to do plus. And then I'll do again. I'll go back to second distribution and normal CDF. And the lower bound this time is 2.5. So 2.5. The upper bound is negative, actually it's positive. So positive 2.5, so 2.5. The mean is 0, mean of a standard normal. Standard deviation is 1. So I'm going to paste. I think I need to go back up because the upper bound should be 1e to power 99. So 1 e to power 99, second comma, e to power 99. So lower bound and upper bound mean standard deviation. So I want to make sure, I'm going to go down and test. When it gives me what I'm looking for, I have to eyeball it very well, make sure that it's correct. If it is not correct, I'll go in and do the corrections. Okay, so that's what I'm asking for. Then I'll hit enter. And my answer is 0.0. And that's going to be, and when I hit enter, yes, I did. So I have, so the answer from the left plus the answer from the right. So I already added them, but maybe I have to do them differently. So I want to do them differently just to make sure. So what I'm going to do, get the first one and store it in X. So clear. That way, I want to make sure that cannot just fail a simple question. It's a simple question. So I will do it again and store my first answer in X that way. So second distribution, normal distribution, and then negative 1/8 to the power 99. So remember, you're a human being and you can actually cross-check your answer. Be careful to check your answer. Make sure it is correct as much as you can. Negative 1.54, negative 1.54. And the mean is 0. The standard deviation is 1 for a normal curve, standard normal curve. So I'm going to hit enter. And I'll be careful to store my answer, store my answer in X. Why? I want to make sure that my answers are, so this is my answer for first part. Then I will do number 2, the second part. I want to do the second part separately. So I'll go back, second distribution, normalcdf. Okay, so the lower bound this time is 2.5. 2.5. And the upper bound is positive infinity. And so it is 1. And where is E? Under comma, 1e to the power 99 is positive infinity. Okay. And then mean is 0, standard deviation is 1. I'll enter. And I'll look back and check. Is my answer correct? Yes. See, this is asking you, is what you put in correct? So it's correct for me. All right, so my answer for area to the right is 0.006. So what I'm going to do now, I can see now that the first answer we got is correct, but I just wanted to make sure. So I'm going to say plus whatever I stored in X plus X. I hit enter. Therefore, the total area on the left and on the right is 0.068. 0.068. So total area is 0.068. 0.068. 0.068. I can put 0 here, nearest 10,000. Okay, so the total area is here. Be careful whenever you're told to find the total area to the right and area to the left. You make sure you read the question very well. Okay, now let's go and do C. So by the time we do finish this number 25, you already know how to find the area under the normal curve using your calculator. But actually do one more number. That way, you won't have any problem calculating area under the normal curve. All right, one more area under the normal curve. One more question on area under the normal curve. That is 25C. 25C. This question says find the area under the normal curve to the left of negative 0.28 plus the area under the normal curve to the right of 1.4. Almost the same as what we just did. But let's do it. Because today, the remaining part of the day is normal curve. So don't have any other thing to do. So I am going to first of all draw a diagram. Any question on normal distribution, draw a diagram. All right, so the boundary line is negative 0.28. On the right-hand side, it is 1.4. 1.4. And I'm told to find it to the left and find area to the right and add them together. Okay. And by the way, I hope you know that this is Z and the Z2. All right. The same argument. The same argument. You write the arguments down for, because anybody wants to know if you know what you're doing. So I will write normal cumulative density function. Area to the left of this is, you know, it is the left. Therefore, this is negative 1e to the power 99. So negative 1e to the power 99. And 0 0.-028. And I wanted to know that negative infinity is lower than negative 0.28. The mean and the standard deviation plus area to the right, cumulative density function. Area to the right of 1.4. 1.4. Okay, so 1.4 is the lower bound. The upper bound is positive infinity. The mean is 0. Standard deviation is 1. I know why I'm doing so many examples in normal distribution again, because you really can't do statistics without knowing normal distribution. Okay, so I will calculate the first one and I will store it in my X, and calculate the second one, store it in my X also. All right, I mean, add all of them together. Okay, so I pull my calculator up. My calculator up, clear. And as I clear it, I just want to make sure I'm doing normal distribution. So I'm going to second distribution number 2. So make sure you're doing normal cumulative density function. The argument in the first part says negative 1e to the power 99, negative 1. How do I get e again? Go to above comma. The upper bound is negative 0.28, negative 0.28. The next one is mean of a standard normal is 0. Standard deviation of a standard normal is 1. So I'm going to check to see if what I typed in is correct. Is this correct? Yes. So I can continue. When I hit enter, I'll get the area to the left. Now I got area to the left, and I'm going to store it, store in X. So I'm going to store it in X. Then I will find area to the right. Move my calculator so I can see. Now, area to the right, I'll go back second distribution number 2. And then the lower bound, 1.4 is lower than positive infinity. So 1, 4. The upper bound is positive infinity. Therefore, I'll type in 1 e to the power 99, e to the power 99. All right, the mean is 0, standard deviation is 1, and I will paste. Is this correct? Is that what I'm supposed to type in? Yes. So I hit enter. Now I get an answer. So I'll add the answer I stored in X to this answer plus X. And I hit enter. Therefore, the total area is 0.4705 to the nearest 10,000 or to the nearest 4 decimal places. The nearest 4 decimal places is 0.4705. So my answer, total area, is 0.47, 0.4705. Let's see. So that is the total area. And be careful, sometimes when this question is asked, some people don't even look. They just find the area to the left because they did not see the complete question, or they did not read the complete question. Really want to get all the answers. The text is not difficult if you have been paying attention, but you just want to make sure that you don't fail simple questions and you know how to use your calculator. Knowing how to use your calculator will help you a lot. If you prefer reading the chart, we are reading the chart very soon. Some people actually prefer reading the chart. Whichever one you like, do your best. So this is question number 25. I'm going to go up again because we're only doing a normal distribution today. So I'm looking for, I might look for any between. Is there any normal distribution question that is between? So let's see between question. Is there any question on between? Because very soon we shall be given between. This one is central limit theorem. So we're not going to go there yet. That is not normal distribution. That is central limit theorem. Okay, so if there is no question on between, I will actually give one. Let me see. Oh yeah, that's one. The area that lies between. Good. So question number 16, we have between questions. So we can answer one more question. In number 16, there are between questions there. So the first thing we want to do is we are told to find the area between. So the first thing we want to do is draw a normal curve. Draw a normal curve. The lower bound is negative 0.74. The upper bound is 0.74. The absolute value of these two numbers are equal. Therefore, we shall use the symmetry of normal curve. If I find the left, I multiply it by 2 because the absolute value of any of this is it's going to be 0.74, 0.74. So that makes the word easier. So we calculate area to the left and multiply by 2. Okay, let's do that. Calculate area. And if I'm told to find, like in number 2 here, B, the absolute value of these two numbers are not the same, so you have to do them differently. Also in C, the absolute value of the numbers, they're between, but you cannot multiply one because the absolute value of those numbers are not the same. And by the way, let me make sure let's go back to my drawing. My drawing looks, the question here is area between. I have to correct myself. In fact, I have to draw so I'm going to draw another normal curve because actually the question is on between. The question is on between. So I caught myself drawing a wrong diagram. I got to draw it again. So I'm told to find area between. Why? So I'm told to find area between. So I got to be careful. So negative 0.74 and 0.74. And I'm told to find the area here, shaded region, not area to the left and area to the right. So please read your questions. Human beings make mistakes. Doesn't matter how long you have that. So I'm told to find area between this. So let's see the argument I'm going to give my calculator. Normal cumulative density function, lower bound, upper bound, mean, and standard deviation. Because this question is between. So I'm going to rewrite normal cumulative density function. The lower bound is negative 0.74. The upper bound is 0.74. The mean is 0, standard deviation is 1. I don't even have to put the mean. I can actually use only a lower bound and upper bound because it's a standard normal. All right, so I get my calculator and I will pull up normalcdf. Number 2, the lower bound is negative 0.74, negative 74, negative 0.74, and the upper bound is 0.74, and the mean is 0, standard deviation is 1, a standard normal curve. We hit enter, and now eyeball what that is correct. So the area in the middle is 0.5407 to the nearest 10,000 for decimal places, 5407. So that is the area between. So when you're told to find the area between, you have to use this argument, area between. And remember, you can be told to write your answer in percent. So my answer in percent is 54.07%. Like you can always be told to write your answer in percent. All right. I think I'm going to let you do the remainders because there's not a lot here. Just you just need to know how to do one, and the others are just like that. Simple. Okay. For the B part, area between. So you draw a diagram. This is the mean, by the way. Z equal to 0 is the mean. You can use the chart or use the calculator to do it. So draw the diagram. The left bound is negative 2.07. The mean is the line of symmetry. The mean is 0. And I'm looking for area between. So shaded region. So what I'm going to do is get my calculator. Actually, this is the argument for my calculator. Normal cumulative density function. Lower bound. The lower bound is negative 2.07. The upper bound is the mean. The mean of standard normal curve is 0 again. Standard deviation is 1. And then I'll type it in my calculator. And I'll get my answer. So let's go. So I get my calculator, type it in. So normal cumulative density function, area between negative 2.07, negative. Be careful to use negative in parentheses when you are starting, 2.07. The upper bound is 0, which is the mean. Mean of this number is standard number is 0, standard deviation is 1, and I'm going to paste. When I hit enter, the area is 0.4808. So that area is 0.4808. 0.4808. 4 decimal places. 2%. 48.08. Don't forget percent. The tool to write it in percent. Don't forget the percent. And so on. You can solve any question for between. Now you should be able to solve, find the area under the normal curve, area between, area to the right, area to the left. So we concluded normal distribution today. Well, next class we shall talk about central limit theorem, chapter 8, 8.1. And by the way, if you do not know normal distribution,